Hello friends, in this video I'd like to solve the following problem from the Croatian Mathematical Olympiad, 11th grade, 2003, problem number 2. We want to prove that n floor of n times n plus 1 over 4n minus 2 equals floor of n plus 1 over 4 for every integer n greater than or equal 3. It's a nice problem. Here are my hints. First, notice that if we have some integer k and some real number a, then floor of a equals k if and only if a is between k and k plus 1. Here we have weak inequality, here we have strict inequality. Moreover, you should write that n plus 1, which appears right here and right here, it equals 4k plus some remainder, where k is greater than 0 and r is one of these 4 possible remainders. And basically, you should use these 2 hints and check case by case. There will be 4 cases in the end. So give this problem a try and I will see you in just a minute. So as I suggested, let n plus 1 be equal 4k plus r, where k is a positive integer and r is one of these 4 numbers, 0, 1, 2, or 3. Well, you may ask, how do I know that k is positive integer? Well, because n is greater than or equal 3, so n plus 1 is greater than or equal 4, so k must be at least 1. At least 1. Very well. And now let's transform our equation. So, we have the following. Instead of n, I can write 4k plus r minus 1. Instead of n plus 1, I have 4k plus r. And in the denominator, I have 4k plus r minus 1 minus 2. Close our floor. And on the right hand side, we have k plus r over 4. Now, what can we do? We can take the entire left hand side and we can expand it. So we have 16k squared plus 8k times r plus r squared minus r minus 4k. Very well, if I'm not mistaken. And in the denominator we have 16k plus 4r minus 6. And what is floor of this number on the right hand side? Well, it's just k, because r over 4 is between 0 and 1. And now, using my first hint, this equality happens if and only if our number under the floor is somewhere between k and k plus 1. And now we wish to verify these 2 inequalities. So let's get rid of the denominator. And now, dirty work, we have to multiply everything. 16k squared plus 4kr minus 6k less than or equal 16k squared plus 8k times r plus r squared minus r minus 4 times k less than 16k squared plus 4kr minus 6k plus 16k plus 4r minus 6. Now, times for some cancellations. First, notice that here we have 16k squared, here we have 16k squared, and here as well, gone. What else? Well, here we have plus 4kr, so we can cancel with 8 and we have 4. 4kr here as well. What else? We can add 6k, so we have minus 6k, and if I add, I will have plus 2k. Let me look at my notes. Is it right? It is probably, hopefully. Yes, it is. And what else? Oh, let's leave it at that. So our inequality is equivalent to saying that 4kr plus 2k plus r squared minus r is less than 16k plus 4r minus 6. Now we have verified this. Notice that first inequality is obviously true. It's obviously true. Why is that? Well, because this is greater than or equal 0, and this is definitely greater than 0, because 2k is positive. So the first inequality is true. Very well. So now we have just to verify our second inequality. So in other words, we have to verify what can we do. We just want to verify 2kr plus r squared plus 6 is less than 14k plus 5r. We have to verify that. And now let's proceed by case, basically. If r equals 0, what do we have then? We have 6 less than 14k. It's true, it's obviously satisfied because k is a positive integer. True. If r is 1, what then? If r is 1, on the left-hand side we have 2k plus 7, and on the right-hand side we have 14k plus 5. In other words, 2 is less than 10k. Obviously true as well, for every positive integer. Next case, r equals 2. Well, then we have 4k plus 10 less than 14k plus 10. In other words, 0 less than 10k. Sorry, something is amiss here. Is right. Sorry, my bad. There should not be 2kr because we have 4kr. Sorry about that. So in the first case it was okay because it was 0 times kr, but here we have 4k and now it's true. Now this is well, and here we don't have 4k, but this time we have 8k. Sorry about that. So it's not 10k, but it is 6k. And again, it is true. It is true. And finally, final case, if r equals 3, then if r equals 3, then we have 12k plus 15 less than 14k plus 15. So we have this time 0 less than 2k. It's also true. So in every case, our inequality, both of our inequalities are true. So now we know that this right here is also true, which is equivalent to saying, all of that was equivalent to saying that our quality with floors actually is true. So that closes our proof. And that closes our video. So thank you very much for watching. I will see you next time. Goodbye.